In this video, we are going to evaluate some simple variable expressions, and I'll show you what that means in just a second. So let's take this example here. We have 4x plus 9. We want to solve this when x is equal to 2. And what we're going to do here is actually just plug in 2 in place of x, because these values are exactly the same, right? X is equal to 2, so they're interchangeable. So what we're going to have here is 4, and I encourage you to write the x values in parentheses just so, it's a little less confusing. So we have 4 times 2 plus 9. And now we just have a simple two-step PEMDAS expression, right? So here we have 4 times 2, we do multiplication first, and then this is 8 plus 9, and then this is just going to be 17. Now let's solve this. So solve 3x to the second power plus 1 when x is equal to 3. So let's just plug in 3 for the x. Since 3 and x are equivalent, this means they're interchangeable. So we will have here 3 times 3 to the second power plus 1. And we'll do PEMDAS, so we have an exponent, so let's evaluate this first. This will be 3 times 3 to the second power is 3 times 3, which is 9, plus 1. Let's see, 3 times 9 is 27, plus 1. So our answer here is 28. Now we are told the amount of money Maria saved after X weeks is given by the following expression. And here we have 1/2 times X plus 10. And we want to know how much money Maria saved after 12 weeks. Okay, so our expression gives us the amount of money after we know how many weeks have passed, right? And this problem tells us that this problem asks us how much money she saved after 12 weeks. So our value of x here is going to be 12, since x is in weeks, right? If it was 1 week, x would be 1, and so on and so forth, right? If x was 3, there would be 3 weeks that have passed. So here there are 12 weeks that have passed, and we want to know how much money she saved. So let's just plug in 12 for x here. So we'll rewrite this expression. We will rewrite this expression as x equals 12. Let's see, 1/2 times 12 is the same thing as 1/2 times 12 over 1, and that would be 12 over 2, or 12 divided by 2, which is 6, plus 10, and then 6 plus 10 is 16. So our answer to how much money did Maria save after 12 weeks? She saved $16. Now we are told that the following expression represents the life of a battery after X hours of usage in percentage. And this expression is -2 times X plus 50. And we want to know what percentage of life does the battery have after 15 hours of usage. And I encourage you to try this problem on your own. But when we are dealing with problems like this, I think that it is a good idea to understand, first off, what the whole expression is representing, and then secondly, what x represents, so we know what value to plug in. So this problem tells us that the whole expression represents the life of a battery, right? Life of a battery, and we can underline that. Right, and this is the expression. And x represents the hours of usage, right? The hours of usage. And we want to know what battery life does it have after 15 hours of usage. So we know x represents the hours of usage, so we're just going to plug in 15, since in this expression x is equal to 15, right? So this is going to be, we'll rewrite this, we'll say -2 times 15, since x represents the hours of usage and we want to know how much battery life is left after 15 hours of usage, plus 50. So we will do PEMDAS, and there's multiplication right here. So 2 times 15 will be 30, but since there's a negative being multiplied to a positive, this is going to be a negative. So this will be -30. I'll scroll down a little bit. -30 plus 50. And the commutative property of addition tells us that we can switch this order here. So this will be 50. See, this will be 50 plus negative 30, right? 50 plus negative 30. But we know when we're adding a negative, that's the same thing as subtraction. So this is 50 minus 30. And then 50 minus 30 is just going to be 20. So what percentage of life does the battery have after 15 hours of usage? It has 20%. Now let's do one more problem. So now we are told that we earn $7 babysitting per hour and we get a $3 bonus. We want to first find an expression that gives us how much money we earn after X hours and then how much money you would make if you babysat for 5 hours. So we have two questions I need answering. So let's do number one first. So we want to find an expression that gives you how much money that you earn after X hours. So to do this, let's find out what the expression is going to mean and then what X is going to mean. So the expression is going to give us how much money we earn. So expression, we will say just money, right? Expression is the money. And then we earn after X hours. So X is hours. So the total money, let's see here, after X hours. So we know that if X increases by 1, the whole thing is going to increase by 7 because we earn 7 extra dollars an hour. So this will be, we can start out with 7 times X, or we will write 7X. And we know this is true, right? Because we've worked 1 hour, we would make $7. Of course, right now we're ignoring this bonus. And then if we work 2 hours, it would be 14. And then if we work 0 hours, this would be 0. And then we get a $3 bonus, right? So no matter how many hours, we will get plus $3, right? There's going to be $3 extra dollars added on. Plus 3. And actually, let me rewrite this in a different color, right? So let me rewrite this. 7x plus 3. Okay, this is our expression that gives us how much money we will earn after X hours. So I'll write this here, 7x plus 3. And we want to figure out how much money we would make if we babysat for 5 hours. So we know X is equivalent to the hours that we work. So if the amount of hours that we babysat is 5, then X is going to be 5. So we can rewrite this expression and plug in 5 for X. So I'll just do this, 7 times 5 plus 3. Okay, now we can do PEMDAS. So 7 times 5 is 35 plus 3, and then that is 38. So if we were to babysit for 5 hours, we would have earned 38 dollars. And we are done.